Hi, this is still section two. I had a little glitch in my recording, so I'll kind of start where I think I left off there. There's the prime polynomials where they talk about showing this. Basically, if you look at factors of 5, this last term, and again, I can't emphasize enough understanding this strategy or basically this process is when I look at this, I know that my first term is x, and I know that my last term is going to be factors of 5. Well, really x squared, are the factors of x squared, right? So it means the same thing on it. I got the first times first here, last times last of that FOIL, right? Well, in this case, I can look at say, well, I got x and x, and let's look at factors of 5, which is a prime number, so that's pretty easy to see that we only have 4 factors here, the positive 5 times positive 1 and negative 5 times negative 1. And I get these possible sums, right? I only got 2 possible sums in this case, which is 6 and negative 6. Well, the sum of the middle term here is a negative 1. So there's no possible way I can write 2 binomials to multiply together to get this trinomial. So in other words, we're looking at the fact that there is only 2 factors to this, one in itself. That's why they call it prime. The other thing, and they talk about here what prime means again, and the other thing that comes up is we got to make sure that we factor completely, and we're going to look at a couple of things here too. And the best strategy is to always look for common factors first. That's what we did in the prior section. And I see that when we're doing the more complex factoring, you tend to think, hey, I got to do this way. It's actually possible to do it that way, but boy, the complexity of it goes way up. You end up with a lot of factors to deal with. So always look for common factors first. Like in this case, I have these terms here, and it really kind of jumps out at you and say, hey, I have a x that's common in all these. Do I have anything else? Well, there's actually a 2 in each one of these 2. So I can common factor out a negative, and also it's nice. Well, it's more than nice. It really reduces complexity to make sure the first term of that trinomial is positive. I want this. We've just gone through strategies to deal with this being, you know, a square, really, right? Something squared. Which, when we go back to that diagram of that area stuff, it's kind of nice when this thing is just that x and times x, right? So if we can do that, and that's why they said, hey, I can take out more than 2. I can take out the negative 1 too and take out a negative 2x. The strategy again is a goal. It'd be nice if this is positive. It's not always going to be the case when we're doing factoring, but I do have a choice. Actually, it could be anytime. I can change the sign of any term I want in any polynomial by factoring out a negative 1, right? I can change signs by factoring. So in this case, they take out a negative 2x, and now I have this trinomial I need to factor. And then be careful not to forget about this negative 2x. So now you take your strategy. I got factors of 25, which could be 5 and 5, negative 5 and negative 5. But notice that they only listed the negatives because, hey, the only way I'm going to get a sum that's negative when I'm going to either have 2 positive here or 2 negative. The only way it's going to get a negative sum is the negative factors. So they just list those. And they say, hey, negative 5 and negative 5 has a sum of negative 10. That's my deal here. Now the caution is you do this work and you figure out I got this thing really is, and then there's also a pattern here we're going to talk about next. This is really a binomial squared. And if you saw the pattern, you say, hey, I got something squared, something squared. Is this the sum of those 2 things squared, right? the factors of that. And we can, some of you may have noticed, you could jump right to this factoring here. But even if you don't, you do the anti-FOIL, you end up here. Very common mistake is to forget about this negative 2x. If you do algorithmic style work on your paper, give yourself some room. You know, you start some of these problems, you're not going to be sure how many steps it's going to take to solve this. And I see a lot of times we try to skip showing some work sometimes because, and even our checking we could put in an algorithmic style, so I can go right down there and see, hey, it checked wrong. I can just step back up and maybe catch a math error rather than having to start all over. So main thing is look for common factors first. Anytime I can do that, that is a lot easier factoring, is to find a common factor. This would be a real complex trinomial to just factor into binomials first. It's possible, and then you'd still end up having to find a common factor for those, which usually when I see that mistake happen at the end of the work, very seldom do I see students say, oh, hey, there's still a common factor in here. I can factor this completely, right? So make sure you factor completely. And that's the exercise. So a little short add-on here, but hopefully you got both of these videos for this section, and I'll talk to you later.